everybody, and welcome to the February edition of the 3DHP for the Nation Info Forum. As most of you know, we'll be hearing from Sylvia Terziati from USGS today on EDH development, guidance, and specifications. But before we get to the good stuff, just a few quick updates. If you're new to this forum, just a quick reminder that this is the 3DHP for the Nation project is a USGS NSGIC cooperative agreement intended to engage state and local government and private sector partners in the 3DHP program and to not only inform but support them in their efforts to acquire and develop 3DHP data. Just want to quickly run over our current activities. I'm going to turn my video off. We have the monthly forum, as you know. Just a reminder, all forums are recorded. I always get 2 or 3 calls in advance for folks that can't attend. All forums are recorded. We keep the PowerPoints and the Q&A docs, and they're all available at the NSGIC knowledge base. And I will paste these URLs into the chat in just a minute. So anything you missed, you can go back and find it there. We are renewed for the project year, as most of you know, and we've completed the work plan. We do have the culvert mapping good practices community workspace. We do need your input there. I'm going to mention in a few minutes, well, I'll go ahead and mention now. Next month, we'll be having a 3DHP interest group meeting in lieu of the forum, and we'll be talking in more detail about how you can engage with that community workspace. We have the inventory of state 3D hydrography experiences. Please add your information there. There is a detailed and a brief form, and you can get that. All of these are accessible through the 3DHP for the Nation info hub. And also the 3D NTM data acquisition planning guide. This is our primary activity this year, is to expand the existing 3DET planning guide in cooperation with the 3DET for the Nation program and develop a joint guide that'll address acquisition for both programs as part of the 3D NTM. Of course, we have the interest group meeting. As I said, the next meeting will be next month, March 20th, in place of the forum. NSGIC members can join at My NSGIC, and if you're not a NSGIC member, you can still join. It's open for everybody, and I'm going to give you the link to get to mynsgic.com, and that should lead you. As you go through the registration process, it'll lead you to setting up a prospect account. And in addition to the 3DHP for the Nation community, there is a hydrography stewards community, and that's for those that manage statewide hydrography. That includes NHD stewards as well as just general state hydrography stewards. It's open to NSGIC members and non-members. We mention that because we want those state hydrography stewards engaged, and they're oftentimes not the official NSGIC members. So please reach out to your community, and I'll put this link as well where you can send to your state hydrography folks to make sure they're part of that dialogue. There was a meeting in January, and Jane has published the meeting notes, and those are all available from the library at the My NSGIC community. So with all that said, I'm going to pop these URLs into the chat, and feel free to follow up if you have any questions. Let me fix this typo real fast. There we go. Today, we are fortunate to have both Steve Achel and Sylvia Terziati. They're both from the USGS 3DHP program, and they're going to be talking. Oh my goodness, I really messed this up because they're going to be they're not going to talk about Wisconsin today, folks. Let's fix that slide as well. We'll just spend most of our time fixing slides. Sylvia, would you rather talk about EDH development guidance and specifications rather than the Wisconsin program?
I think Wisconsin would appreciate me not talking.
All right. Thank you all for your patience. We're still new in the new year, I'm going to say. So with that said, I'm going to turn it over. Sylvia, did you say Steve was going to open up for us?
That's right. Yep.
Steve, I'll stop sharing if you want to share your screen, or if Sylvia's sharing the screen.
No, I'm actually just going to talk. I only have a few things to say. And I guess the first thing is really, I'm impressed we got 75 people out to talk about hydrography specifications and data validation. This is, this blended world, this is about as interesting as metadata.
Hey, whoa.
I know. But, but it's also, as Linda would beat into you endlessly, it's also critically important to building any kind of scalable national database. We can't have consistent national data in a timely manner without clear specifications and an objective data validation process. And so building these is really kind of a big accomplishment. These are things that we've never had before in the hydrography world. In 1999, we published, or we didn't actually, we only ever got to draft specifications for NHD, and we ran on those for 20 odd years. And then Sylvia and Christiane Archuleta and a few other folks put together the specifications and read rules that many folks on this call have probably memorized at this point. But assembling those over a couple of years and really writing down what should or shouldn't be represented within the database and how it should be represented was a pretty big accomplishment. And then actually getting that published through the USGS processes was another pretty big accomplishment. It took about 2 years to write the documents and about a year to get them through the review processes. And so this puts us on a firm footing for knowing what we're asking for as we're building the 3DHP databases. The other thing that we really never had before in hydrography in any form was objective data validation. Back in 2016, we ran a small set of pilot projects really just to try to understand the cost of data collection. And as we brought that data in and reviewed it, it became pretty clear we didn't know what to look for. We'd have 5 or 6 people reviewing data and get 7 or 8 opinions on how that data should look. And it came back a lot of it came back to that it looked right to a reviewer. And when you're working in sort of the old model of hydrography of a lot of interactive feedback and a lot of acquired experience and expertise, that's one thing. But when we're trying to build out a national program that's going to do about 10 or 15% of the country every year as a target, we need to have an objective process to do this. And so codifying what looks right into a set of tests that a computer can run, and we can run in fairly automated fashion, is also a really massive accomplishment towards making this a successful program. So I'm going to take a couple minutes here just to recognize Sylvia and Christiane and Ryan and Lily and a number of folks that put stuff like that together. This is a big deal. The other thing, and I want to thank the folks that are on the call that have been bearing with us through this over the last couple of years, is that the specifications and review processes have been evolving pretty rapidly as we encounter new conditions in the landscape on the data. I think we're coming out of that period of rapid change. Not to say there won't be more changes or more modifications, but I think we'll have less frequent change, and we can start to transition into a really more operational kind of mode on data collection and validation. And again, Sylvia has been a really huge part of making that evolution possible. And so with that, I'll turn it over to Sylvia to go through the gory details of it. So thanks.
Thanks, Steve. Gory details there are many of. Let's see. Can you all see the screen?
We can. Thank you, Sylvia.
Okay, great. Yep, and so today, like Steve said, we do have new developments because every time we get a new data set, there's something that we haven't thought about. Luckily, we've seen some of the more challenging areas in Southeast Texas where everything is flat and you never know which way something's blowing, to places like Pennsylvania where we have sinks and networks like to just stop, and making sure we have conditions in our specifications for all of those types of situations. We've had to make some changes to our specifications to accommodate things like that. So let's see if I can get this to advance. Here we go. So today I was just going to talk about some of our more recent updates to the specifications and read rules, talk about some of the new guideline documents that we have online and some that are going to be coming soon, and then some of the new ways that we are trying to streamline our validation process, as well as some of the things that we're developing that are a little bit newer in our validation process that might be of interest. So first we'll talk about the specifications. I think you all have seen this slide before. One of the things I wanted to point out is that we do have, can you all see my mouse?
Yes.
Point? Okay, great. We do have a new version of the spec out, the 2023 revision A, that is the most recent specification. If folks want to take a look at that, they'll be able to see all of the newer codes that we're introducing. One thing that I do want to stress is that we don't yet have a schema that matches that new specification available for people to develop to yet, because our tools need to catch up with our specifications. So, you know, it's like a slow moving train. You know, we have to have everything catch up to the same spot before we can release things. So we've got our specifications, we've got our rules in place, but now our tool has to catch up to be able to test to that, and then we'll be releasing the schema so that people can develop to it. But I did want to tell you about the things that are in this new specification, just some of the highlights. We are going to be combining reservoir with lake pond because people were just having a difficult time distinguishing, unless it was already distinguished in NHD as a source document. It was hard to tell if something was a reservoir or a lake pond. Now everything's going to be combined into one water body feature type right now, still called lake pond. But it is it's just going to be a little bit easier to not have to code for these two different types. I know some people really like having that reservoir distinguished from lake pond, but when it's a little bit of an arbitrary distinction, it becomes meaningless if you can't trust it. So we found that just deciding to go ahead and combine those two was going to be least amount of damage. Flow class is another one that people might remember from NHD, actually. We in Southeast Texas quickly realized we needed to be able to say whether or not a feature had flow direction that could be associated with it. So we actually have 3 different types of flow class. You can flow downhill, which most stream features do. You can have no flow associated with it, like a lot of coastal canals and other smaller features. Or we also included a flowing uphill because there were features that we found, again, in Southeast Texas, but probably occur in lots of places where there's pumping, where you had a feature that was lower than another feature that it was being pumped up into. So a canal being pumped up into a higher stream or canal. So we have 3 flow class feature types. We have an E-class differentiation now between different polygons, because again, we had polygons that were already hydroflattened on the surface of a LiDAR data set. And we had polygons that a contractor had to delineate themselves. And then we had polygons that were coming straight from a break line, but the break line wasn't really adequately cartographically suitable, so needed to be updated in some way. So we have these new E-classes for polygon features. We had a lot of revisions just to names and descriptions of fields. When we first wrote these specifications, we were still imagining everything was going to be imported into NHD. So we had a lot of references to how things were going to be conflated into NHD. So we're trying to clean all that up. We added a limitation field, and we are going to separate out DEM limitation polygons as separate feature types. The third, or the last thing I wanted to highlight was just that the source DEM has changed from originally in the specification was going to be the OPR coordinate system. Now we want the entire CONUS to be in one projection so it can be seamless. That's going to help us keep all of our HUCs flowing from one to another, and smaller areas are all going to be well integrated together, and we won't have issues when we're trying to, create that national data set. So there are other updates, and I'm not going to list them all. Probably listed more than you want to hear about already. But if you go to our spec page, you will find all of them listed, and you'll also, if you download a version of the spec, most recent spec as a PDF, it also has everything listed by release, any change that's made within the specification. The other thing I wanted to talk about, just because a lot of people don't really think to go look at this part of our specifications website, are these resources. And under the resources right now, we have some of our guideline documents that we initially write guideline documents for contractors as we find they are having trouble interpreting something in the specification, or we've left something out of the specification, or we just need to clarify it in some way. So we write these documents before they can be released to the public. They need to be reviewed by a number of different people. And once they are reviewed enough to make sure they're not violating all of our, USGS standards, they can be placed on our guideline documents website. So that's a long way of saying, if you come to our standards page, look under resources, you'll see some of our read rule guidelines. Right now, we have 6 guidelines that are there. The 2 newest that are online have to do with the infrastructure connectors and XY precision. Infrastructure connectors, we have a description of what makes an infrastructure connector, when to use it, how to place it within the network, how to code the Z values, all of that sort of information. XYZ precision, we have a lot of information about how to capture the coordinates, to what precision. But we also have an entire section that is devoted to how to make the water body boundaries match the elevation surface, because we were finding that was taking a lot of effort to make water body boundaries match a hydroflattened surface instead of just using hydroflattening break lines directly from a LiDAR collection. So that was a fairly major difference that came out of that precision document. These are the ones that are on our contractor guideline site, so right now I just talked about these first two. There are the other four with the yellow arrows are ones that are also on our publicly facing site, but these other documents that haven't gone through our complete review or still in draft, or we're still maybe not quite ready to say this is the final way that we'd like things to go. Those are still in process and we haven't released them yet. We are trying to streamline our process so that we can push those guideline documents through review a little bit more quickly, so that they're published publicly, shortly after contractors get them. In some cases, that's possible. In other cases, we really want to test them a little bit before we say this is the way we want them to be. So some of these you'll see more quickly than others, but we are trying to make it a little bit faster to go through that process. We have a great standard specialist who's working hard on getting all of these organized and out onto the web, so very thankful for that. All right, so I'm going to jump into some of the changes we have now with our validation process. I think you all have seen kind of this schematic. This is just a very simple way of showing how we get our EDH data in, our elevation derived hydrography data. So we receive it from a contractor. All of our contractors get a task order that have our requirements in it. They all reference our specifications, so they know that they need to meet our specifications. That includes any of the guideline documents that are on that contractor site. As soon as they get that task order, they have access to all of that information. And then we go through our validation process as we receive our data. So when we receive our data, we now have two steps, our staging and our validation tools. Our staging is kind of the, you have to meet these things or we can't even proceed because all our tools will break kind of thing. So we really have a zero error acceptance at that stage. And then we have our validation tools, which we've been working on for, as long as this project's been going on. And we keep adding to them, making them a little bit easier to use, easier for our validation team to use. Now it's completely automated so that it is just fill in, the paths to the data and run it and get a report. So it makes it a lot easier for us to get results back quickly. These are the things that you probably can't read at this level, but I'll zoom in a little bit on them in a minute. But this is how we design our staging and our validation process. So we have a number of things we look for in staging, number of checks we do in validation. The staging, again, is really set up to make sure we can run our tools against the data. I think one of the things that has come out most recently is that we really need to be scrutinizing the DEM that we're getting more closely. In Alaska, we were providing, or still are providing, the DMs to the contractor, so we didn't really worry about the way that DM was being pulled together. Now that we're getting DMs from, all sorts of places with all sorts of LiDAR data being merged together in various different ways, resampled in different ways, we're finding that we really need to pay a little bit more attention to that DEM because everything is based on that DEM. Everything is derived from the DEM, all the Z values. So if there's weird artifacts or the coordinate system isn't quite right, the Z values are going to be off in our EDH data. So our emphasis on the DEM checks really are based on the fact that we are going to be using this data in our 1 meter seamless product eventually once we have that for the whole country. So we're going to be using the contractor delivered DEMs to put into our 1 meter seamless. We want it to match, in coordinate system. We want to make sure it's snapping and the geoid's the same and the cell size is the same. All of those things that make sure raster data fits neatly together and it doesn't have, gaps and, slight differences between cell registration and all of those good things. We also are requiring a special metadata data set that has the LiDAR tiles that are used to mosaic the entire area, and a metadata report specifically to how the how that data set was compiled for the DEM, the source DEM. We're also requiring different or a specific resampling method of bilinear. So so nobody's using a resampling technique that might introduce artifacts. And then our biggest thing is we look at it and make sure we don't see anything that's off. And on the right here is just the beginning of our guideline document that we provide for the source raster and vector data requirements. And we provide that to all our contractors so that they know what to expect. So this is an example of the types of artifacts we were seeing that kind of made us step back and say, oh, we better take a closer look at some of these data. So we see some striping, we see some cross-hatching. These things tend to happen when nearest neighbor or some filtering maybe goes awry. So we do look at them pretty closely for those kinds of artifacts. We also ask the contractor to compare, if they're projecting something from the OPR, the source LiDAR data, to just look at what they've projected against the OPR and make sure that it looks the same, basically. So if you don't see any artifacts on the OPR, and once you've projected it, you see a bunch of crosshatch, that's not a good sign. So something went wrong in the way that it was projected. So our validation tools, once we've gone through that staging, we've accepted the DEM, we've accepted the EDH data, we run it through our validation tools. Our validation checks are listed here on the right. And each one of our tools returns just a little report like you see here at the bottom, telling us what tool has been run, what it's checked for, and any errors that were found with the automated checks. So for each one of those, we will get this little report, and we're able to summarize our deliveries and decide, pretty quickly whether or not it meets our thresholds for various error types. And also we can pull out the flag features that our validation tools do and provide them back to the contractor so that they can review them for changes in the way that they're automating their own processes or checking for errors themselves. One of the things that we use pretty consistently for our horizontal check that I just wanted to talk about it because we have a few new validation steps that we're using with the GMI or our geomorphic index. So right now, every project that we receive, we create a GMI for. It's a combination of 1 to 4 elevation derivatives. All of our checks for horizontal accuracy are based on the elevation surface. So our GMI is based on those elevation derivatives from that source elevation DEM that we get from the contractor. What it's used for is to model where channelization or low areas are within the elevation surface. And as you can see on the right, with just the imagery, it's very hard to find, at least on the East Coast. It's very hard to find channels on the surface without looking at the DM and looking at the at where channelization probably is on the surface. So the surface itself, the elevation surface itself, gives us a lot of ideas about just looking at it, where we would see channelization and where we would expect a stream to be. And then when we derive the GMI with those geomorphic derivatives that look for channelization, it becomes very obvious where the darker colors or more geomorphic indicators exist, and where the main channel would be, and how that should be derived off the surface. And here's just an example of streams that were delivered and the imagery. And another nice thing about the GMI actually is that it does not cross over things like a road, so you can find those culverts pretty easily where you see a gap and a pit where that GMI might end, and you can see where that culvert should go. So how do we use the GMIs? Right now we have a number of things that we look for with the GMI. It's primarily tools to see if the stream network is either inside or outside of the channel. Sorry, I'm losing my train of thought. Yeah, so channelized features are streams and canals. We want to make sure those are in channels or in our GMI. And then we have connector types or drainage ways, indefinite surface connectors or drainage ways that are actually outside of a channel. And if they are within our GMI, then those are actually flagged as potential errors. So here's a way that you can take a look at how we would use the GMI. This is going through kind of a shallow, low area in the terrain. So it's kind of meandering along. It goes out of the GMI. It comes back into the GMI, goes out again, in again, out, in, out, till it hits a culvert. So so you can kind of see the purple below it. It's in a little bit of a channel within this area, but then it does jump out. And what we do is measure these little segments that are out and see if enough of it is out that maybe it should be called a different feature type within that portion of the stream. And if it's more than 25% out for the entire stream, then we flag it as potentially being, misaligned. Perhaps it should be going through this, this canal instead of, into this, floodplain area, that kind of thing. We also rely on the GMI to tell us whether the stream or the features are channelized or unchannelized. So we do differentiate between drainage ways and definite surface connectors as things that are unchannelized, and stream rivers and canals as things that are channelized. So it is a good way for us to just check our F codes as well, our feature codes, to make sure that things are being coded correctly. And this is another example. We do take a look at some of the errors when we get them. It's not all completely, blind validation. When we look at the data and try to look at where we might be seeing errors, if we start seeing these orange lines are where things are outside of the GMI, and if we see all of the headwaters are outside of the GMI, we could potentially talk to the contractor about, well, maybe you're extending your line work too far, or maybe you're catching drainage ways that should have been coded as drainage ways instead of as stream rivers, that kind of thing. We can also use it to find places where maybe streams are overmapped. Maybe this is a flow path potentially, But if it's not within any real channelization, that could be an indication that they're overmapping these features, and really a lot of them could be dropped without losing any of the network integrity. Or in a third example, we have, in this case, a large section of the stream, which is going from channelized to unchannelized to channelized again. If this is a long enough section, we might suggest that they stop the channelized feature at this point. So this would be a stream river, this would be an indefinite surface connector, and then again a stream river. And the reason we have these indefinite surface connectors in there because we are less sure of the actual presence of a stream there. And so that F code can be used in a number of ways. It can be used as an indication of less certainty. It can also be used as, a stream that maybe has a different characteristic than some of the channelized sections of the stream. And in this case, we have a large section of stream that's outside of the GMI, and it looks like maybe they just, didn't follow a channel, and it's coming across an area that maybe shouldn't have come across. So the other tools I just wanted to touch on briefly are our COD tools, which stand for culvert omission and depressions. So these are some new tests that we don't even really have thresholds for right now, but we're kind of still in the testing phase of how we might automate it or validate it without having to, or with better thresholds, so we know what the real errors are versus just flags that we're throwing back out. But basically they're looking for streams that don't extend through culverts, improperly delineated culverts, sinks in the landscape where a network might end, or sinks in the landscape that might create an issue with connectivity. And I think, I know I've talked before about hydro enforcement of our products. We do have these ways that we do test for hydro enforcement, and that's really important to our data model. So these COD tools help with that aspect of the data model, making sure that everything is hydro enforced and that channels and are present and all of the network requirements are met. So our culverts, I think everybody's familiar with the culverts on the landscape. We've certainly heard about culverts a lot in this group, and I appreciate everybody's enthusiasm for culverts, because I know I was pushing hard to get those culverts into the data model. So I'm glad people recognize the importance of them. They really are very important for breaching, but then once they're identified, it's really a great set of data that can be used for lots of applications. And what we have found is about a fifth to a third of our CONUS, our CONUS data deliveries are made up of these connector types. So it's a very large number of features. Of course, they're very short, so it's not a very large number of stream miles in relation to the entire data set, but it is a lot of features. And they all tend to be breaching features. So we want to make sure that those features are placed in a way that when they're enforced into the surface, are actually breaching that surface and creating that network connectivity all the way from upstream to down. So we have some errors that we look for. The culvert check looks for when the end node is at or below the start node. So that's also checked in our monotonicity checks. We always want to have things flow, the Z values either be at or below the upstream Z value. So this is actually a redundant test, but it's in there. We want to make sure the elevation rise on the surface is at least 0.2 meters. And if the length is greater than 100 meters, we flag it just to make sure that's really a culvert, because those are a little bit unusual, but they certainly exist, especially with large roads, wide roads. So here's an example of a low rise in elevation that was flagged. So we have kind of a dip in the surface rather than a rise in the surface. So the profile looks like this. Ordinarily, you'd expect the culvert to go through a rise in elevation. So in cases like this, we don't actually expect it to necessarily be an error, but it's definitely not something that's needed for breaching. So it can stay in there if people are comfortable that it's a culvert, or if we see no evidence of any kind of road or trail, we'll probably flag it and say that it should be removed. Our omission tool is one that we use just to find large areas of the GMI that don't have any streams associated with them. Now, we do have a lot of areas in the GMI, which, you know, if every little nook and cranny was mapped as a stream, it would be overmapping quite a bit. So we don't expect everything to everything with a GMI to be mapped. But if there is a large area in the GMI that has no stream associated with it, we do flag that as a potential area of omission. We also look at depth for this particular test. And then our last tool is the depression tool, and that could be, again, very helpful in finding culvert omissions. So we fill the surface and look for places that are filled, and and find the low point within the filled area. And if there's no breaching feature below that area, then that's flagged as a potential culvert error omission. We do find a lot of true sinks that way, and that could be handy in karst terrain. We don't expect those to be connected to a network because they're probably not connected to a surface water network. And we do use those as identifying places that a network should end. Okay, so other things that we're kind of working on, tightening up the definition of channelization so it's more consistent across deliveries, and that we can have our tools measure exactly what that is. There's been a little bit of confusion, partly because we aren't providing GMIs right now to all CONUS deliveries. We do in Alaska. So we're looking a little bit at apples and oranges when we look at GMIs, but we're still trying to make sure that our specifications reflect what we're testing for. So that's something we're working on. We're trying to come up with thresholds that are reasonable for all of our validation tests, so that we can, you know, say with confidence, we only have, you know, X number of errors associated with this. And it tends to be pretty small number of errors, but it's very hard to find something, you know, a data set that has 0 errors. We also have some great workflow coordinators right now, and that's been helping a lot. Just reviewing the tools, making sure the tools are in sync with the specifications and with the schemas. Streamlining the guideline review. Again, I mentioned that earlier. We're limiting the update to specifications to twice a year, and also to schemas, hopefully less than that. And I think things are starting to level out so that we aren't having so many changes, just because we're seeing so many, you know, we've seen a lot of different cases now. So hopefully we've got a lot of different things covered within our tools and specifications. We are looking at a new area in the arid west right now with playas, so we may have a few more changes coming, but for the most part, we've looked at a lot of different areas and found cases that we've tried to accommodate within our specification and guidelines. And this last one, folks, I'm sure will be interested in. We are working on tool availability for others to use to validate your EDH against the specification. So the same tools that we use, we're probably at least a year away from that. So I don't want to get people's hopes up on that, but it's a slow process getting those things approved to be served, even if it's on an internal, server, with a restricted access. We still want to be able to do that. It just takes a little while to get there. So hopefully, have some patience with us as we work through that. We are trying to accommodate that. And that's it. So glad to answer any questions.
Thank you, Sylvia. We've got a few questions in the chat. The first one came in from Frank Nelson. He says, you mentioned break lines for open water bodies using elevation data. Do you foresee break lines also incorporating some sort of imagery to better represent permanently ponded locations? As it is now, the lines reference the snapshot in time when the LiDAR was flown.
Right. Yep. And that's an ongoing discussion. We right now, just our main focus is having the 3D HP reflect the elevation surface. So we do rely on those hydro-flattened and hydro-flattening break lines to define where that open water is. That's not to say that in the future we won't have other ways of defining, like ponding elevation and other things that I know people are interested in incorporating into their analysis and models. Certainly, once we start getting topography as part of the 3D NTM, we'll be looking at how that can be used to, model different lake elevations and that kind of thing. But currently, we're collecting just to the hydroflattened surface.
All right, Frank had another question. He says, I like the inclusion of the GMI to verify the hydrography and the continuity of flow paths. Here again, are you exploring the opportunities to use imagery as part of this verification process to tip the scales one way or the other? We've seen locations with groundwater discharge that the flow path was visible from imagery, but the lack of channels and vegetation made it difficult to discern from solely using LiDAR.
Mm-hmm. We do not require imagery to be used by contractors when they're creating the data, but they can if they have an area that's, for some reason their algorithm is doing something odd and they want to check what's going on there, they can use imagery. When we're validating the data, we usually don't use imagery for most of our checks, but I wouldn't say that we don't use it at all either. Certainly when there are some issues, that we see and we're just not sure what's going on, we'll pull in the imagery. But it's not a requirement. Again, everything is tied back to the elevation surface, so that really is what we try to base it on. If there's good evidence that elevation is not representing how the stream is actually flowing, then we can tag that. That's one reason we have that limitation field added now to the elevation drive hydrography schema, because we can tag an individual feature with a limitation. What that limitation means is that the elevation surface is actually the thing that is the limitation. So the true location of that stream feature couldn't be determined based just on elevation. So if we have a limitation of 1 on that feature, we know there was probably some other method that was used to derive that. So we kind of have an out if you have to use imagery, but we don't require it. That was a long answer to that, sorry.
I'm gonna probably mispronounce this, but G. Hissler asked, you mentioned a 100-foot max you flag. Is there a minimum length along the stream flow you might flag?
To be outside of the GMI? Yes, 15 meters, I believe is, if it's 15 meters outside, we don't even worry about it. We exclude all of those as errors. They're not considered errors.
Okay. Mike Plivlich asked, has there been discussion about introducing F codes that help to differentiate between monotonic indefinite surface connectors versus non-monotonic indefinite surface connectors? While not a major concern for data administration, where those two feature types have a confluence, uninitiated users frequently perceive those confluences as pseudonodes in the network.
Oh,
If you have additional questions, we can always ask Mike to elaborate.
Yeah, so we do have the F class now that has whether or not there's a flow associated with it. And we have the F code. So you're worried, I guess Mike doesn't mind answering. You're worried that people just see part of an indefinite surface connector with flow and part without flow.
I'm speaking on behalf of the junior staff members at NV5. We have that come up all the time. In one instance, we had a number of features that got merged together because they perceived them as being of the same category.
Mm-hmm.
I'm well aware of the E class and how to differentiate them. It's just that you put that in front of folks who are maybe not as familiar with the schema, and that could be problematic.
I see. Yeah, I think with the I think looking at a combination of E class, F class, and F code, you'd have to determine if all 3 of those were the same before they were merged together. Of course, we don't have F class as a field yet in the current schema. Once we release that schema, I should say, you'll be able to do that.
All right. And William Seelan, how is duration derived? Also, how does EDH integrate with the NWI wetland inventory?
These are tough questions. Well, they're not tough questions. They're questions we talk a lot about, and we could spend an entire meeting talking about any one of these. So duration, stream permanence is something that we're modeling separately, since we're dropping that as an F code type. So we no longer have that like we did in the NHD. We have a separate project going on right now where it is going to be modeled separately based on drainage area and some other characteristics, and using our USGS stream gauges as control points to determine whether streams, or to classify streams into flow regimes between flowing 0 to 365 days a year. And so once that is done, each place that might have a different definition of what perennial is or what ephemeral is can use those numbers to come up with a definition that suits their own needs. So it will be a separate process, but will be able to be tied to our network in 3D HP so that it can be used for a similar way that our stream permanence classes were earlier. Is that clear enough? Hopefully. As far as NWI, we have a couple of big projects going on in Alaska, and I know some of the states right now are working with NWI as far as making sure the EDH and the 3DHP and the NWI correspond well together. We're trying to come up with a way of linking those two data sets through identifiers so that we don't need to, so if we have a wetland polygon, for instance, you'd be able to tell which 3DHP features were associated with that. It's a little bit different because, again, back to the water body definitions, you know, NWI maps water bodies differently than we do. But at the very minimum, you know, the linear features would not have to be repeated within both data sets.
This is William, if I could just interject. That's one thing that we're having issues with is, as you notice, stream lines jump out of the ditches. And if somebody had gone in and mapped NWI, they will have already mapped that ditch. So it instantly, my line does not match their ditch line. And then the other issue with water bodies, and this is very significant, is that NWI has a lot of water codes to choose from and different vegetation codes. And the area of a lake is very important in Wisconsin for determining different sets of rules and regulations and different enforcement and all this stuff. So if I say a lake is 20 acres based off the break line, and a guy comes in and says, no, I've now say it's 35 acres because I saw these wetlands that you didn't or whatever, then we've got a problem. And they can use that, you know, somebody can then say, hey, my lake says it's 20 acres. You guys say it's 35. I can put my motored boat on there. You know, it's like, well, who's the right one? I don't know. And that's the problem you get in with this, like, really precise data sets that we've created. So it's great, but it causes a lot of stuff.
Yeah, there's no easy answer there except for going out in the field or using imagery maybe but then when is the imagery flown? All of those questions. I mean, there's no real truth to that, is there?
As long as everyone's having the same problems I am, then that's okay by me. So it's very therapeutic that I'm going through this.
You are not alone, William. Sylvia, I want to jump back. G. Hisler clarified, they're talking about, you mentioned a 100-foot max on the culverts, and they were wondering, is there a minimum culvert length you flag?
Oh, no. None of our all of our features have a 1.5 meter length, minimum length. So I guess 1.5 meters. If it's less than that, it might get flagged.
Okay. Bill had a question. He wanted to know, are the resources discussed that you currently only provide to the gypsy contractors also being available to others, such as states, counties who are creating their own EDH and plan to contribute the EDH products they produced at 3DH through a DCA?
We would talk individually with folks to see if they need access to those. We've certainly allowed others to have access to those besides just the contractors themselves. People who are doing review of the data before it goes to contractors or working on their own projects may have a real need to see those. So yeah, just contact us, and usually it's just individual basis. We determine whether, you know, by talking together, whether you want to have or need to have that access.
And did I understand correctly that you are vetting those resources? And once those resources are vetted, they will be on that public resource page?
Yeah, yep. And we have 6 up there now. So, yeah, 6
So
out
it's
of,
just, it's more a matter of timing and validity than anything, correct?
right, exactly.
Bill also asked, when do you anticipate the XYZ coordinate precision guidelines being available?
That one's on, I believe. That's one of the ones, let me look. I think that's one of the ones that is online. Yeah.
They're there. Excellent.
Yeah, these are the ones that are currently online on our standard site. So we have ice masses, vertical integration through depressions, not karst, but through depressions outside of karst terrain, complex interlacing channels, sea, ocean, and the infrastructure in XYZ.
Sue, do you want to come offline and give the clarification that you put in the chat?
Yeah, sure. I just want to make sure folks are clear that the DCA isn't how you contribute data to the 3DHP unless you want to cost share on contracting either through GPSC or through a cooperative agreement with USGS. And there's, I'll give you a link. There's information on how to put in a project submission for the DCA to request cost sharing funds. I will also say that in the absence of a FY24 federal budget, we are on hold with respect to selecting DCA applications. We're working on a process for contributed data to come through to us, but that's not been defined yet. So I just want to make sure there'll be different pathways. The DCA is not for contributed data.
Great. All right. And then James Say asks, do the specs contain the instructions for submitting EDH data for evaluation? My state agency is looking into the feasibility of generating EDH with one of our HUC 10 basins.
You would probably need to just discuss that with us. We don't have right now a way outside of our contracted task orders to contribute data. That's something that's also happening this year. I don't know if Sue wants to address this because she's kind of leading this effort to accept contributed data. Don't mean to put you on the spot, Sue.
Yeah, I mean, yeah, hear the previous comment. We don't have a method, a pathway yet to take in contributed data. And we'll try to get that stood up this year amongst all the other things that we're doing. When that happens, it just depends on the way that we set up the system. But on a broad scale, the data would come to us very similar to how 3DEP contributed data comes to us. And we'll need to have a pathway to validate the data and determine if there are errors in the data that are far enough outside the specification that make us need to request corrections on those data in order to bring them into 3DHP. But that process again is a little bit TBD. We have a few things to put in place before we can get there. James, I hope that answers your question, and please feel free to reach out to me if you want more information about what might the contributed process look like.
All right. Any additional questions while we have Sylvia with us? If not, I want to thank her and the team again for going through this information. As Steve says, it's a bit tedious, and glad to see folks on the line. Let me share my screen again. Jane says this was not gory at all, so that was good. Jane's kind of funny that way, isn't she? She likes this stuff. I'm sorry, I'm having trouble getting my mouse onto the proper page. There we go. All right. As always, the forum is held the third Wednesday of each month, 3 to 4:30 p.m. Eastern. And occasionally we hold an interest meeting, as is the case next month. So next forum will be the 3DHP for the Nation Interest Group meeting Wednesday, March 20th from 3 to 4:30. And as always, if you ever have items to discuss, questions you want to address, please contact me directly and we will make sure to address that. So again, thank you, Sylvia. Thank you all for joining us today. As always, insightful and informative. Thank you all. Goodbye.
Thanks, Linda.